Welcome, everyone. My name is Aaron. I'm an architect, engineer, and sustainability professional based in Fort Worth, Texas. I'm excited to kick off a new series with you all today, and I have two guests that will be joining us for today's session, Harlan Brum and Sasha Crotty. Sasha, maybe you'd like to introduce yourself first.
Sure. So I'm Sasha Crotty. I am the Revit product manager responsible for the Revit platform. So that's multidisciplinary functionality in Revit, as well as the cloud services that we build out with Revit technology at Autodesk.
I'm Harlan Brum. I'm also a product manager in our building and infrastructure group, and I focus mainly on architecture.
Well, thanks, guys. Today, we're going to be talking about performance matters, particularly with Revit. And I want to talk a little bit about this series because this is the first time out. So first, the reason we're doing this is we want to basically share the topics that you've been asking about, whether that's through Revit ideas, whether that's the feedback we see in other forums, or whether that's the open letter that came out recently. We really want to respond and let you know what work we've been doing. We also want you to get to know the folks that are helping make the software, like Sasha and Harlan. We're not going to shy away from anything, and we do want to hear back from you. So please have a listen, think on your questions, and we'll give you an opportunity to respond. As sort of a way to kick this off, I'm curious to know, let's start with Harlan this time. Tell me about the first time you were exposed to Revit.
Well, I joined Autodesk, I think 13 years ago, something like that. And before that, I was practicing architecture in the Midwest and mainly just used AutoCAD and AutoCAD architecture. And so I got hired at Autodesk to be a support specialist here in New Hampshire. And basically the first time I got exposed to Revit was my literally first day on the job, where I got thrown a Revit tutorial book and said, learn this, you're going to be answering questions. So dove right in. And that was basically my first couple of weeks, is learning and becoming familiar with Revit. I think it was like Revit 9 or 8 and 9, I think, at the time when I joined.
What were your initial reactions?
Oh, I loved it. I freaked out because I was like, why on earth was I using AutoCAD? Why did we try AutoCAD architecture? Like, this is amazing. Just when, like, I think drawing my first section and going, holy crap, it updates when I move it without having to do anything. That got me hooked from day one.
And what about you, Sasha? Where did you cross paths with Revit for the first time?
Actually, also when I started my job. So I graduated from college with 2 degrees, one in computer science and one in architecture. And the immediate thought was, okay, well, now what do I do? Where do I go to work? Well, there weren't that many choices at the time of places I could work with that background, where I was really interested in architecture and I could actually do computer science. So I actually joined as a software developer for working on Revit. I worked on Revit Structure for a long time. So I apologize to anybody who's had to use Revit Structure. It is probably my fault. So since then, I became really interested in product management because I thought there was more opportunity for me to help our customers and help all of you get your job done. And that was a switch I made a number of years ago. But the actual moment I touched Revit was probably when I had to take a training class about 4 days, and I thought this was really cool. Like, this is what I've been missing in architecture school. I really wish I had that. So very similar, I think, experience to Harlan, being like, why were we doing this a different way?
Gotcha. In my case, I think the BIM conversation came to my neck of the woods in 2005, and I presented at a corporate retreat. And having made the decision, comparing various tools at the time, and granted, we were AutoCAD architecture users at the time, so there was some bias, but we picked up Revit. And I'll tell you, it was an interesting experience. We were inefficiently efficient, as we like to say, with AutoCAD architecture. We had so much prior work, and we had our 2.5D workflows figured out. So it took probably a year for us to beat the efficiency of what we had in the house. And I remember the first couple of projects, I had this older gentleman sitting behind me, very experienced architect that I was teamed up with. I was the new kid who could pick up technology. He was the seasoned person who could design anything detail-wise. And it was entertainment value, because while I was fine with learning this new environment, thought it was something I could own, he was very seasoned. He was the guy that had brought AutoCAD to the company so many years before. And he would alternately every sentence be, I won't use the exact words, but he would cuss out Revit for being different than AutoCAD for no reason other than to be different. And then the very next line would be, oh, that's pretty cool. So it was great. Anyway, that was a long time ago, 10,000 hours of Revit experience ago or more. And it's been a long road since then. All right. Well, thanks for sharing a little bit about your backgrounds. We're going to jump into the content today, and we'll start right away with a question that seems to never go away, which Sasha is, the users have stated Revit doesn't support multi-threading. So maybe we could start by defining what is multi-threading.
Absolutely. So multi-threading is actually a very specific implementation of parallel processing when a software actually does two things in parallel next to each other. Multi-threading is basically in a situation where you have multiple threads and it's they're essentially sharing data and access to the same data, but it's very specific implementation. So for the most part, when we talk here, we're really going to talk about parallel processing because it's kind of the more generic thing to talk about here. Does Revit do parallel processing is really the question I should be answering. Absolutely, yes. So there are a number of areas in Revit that have parallel processing in place, particularly the graphics layer. So if you spin a model around in Revit, you can start to see that it's using multiple cores on your machine. Rendering is another area that is highly parallelized. Model open is another big one. So this is, when we read from disk, we are trying to do that as quickly as possible. And we also do background processing for exports. We're looking at more of that going, in the future. And also there are a number of enhancements that we've done for things like collaboration with Revit Collab Work Sharing, where we're actually fetching information in the background and caching it for you so it's available and you're not waiting for something to download from the cloud. So those are kind of a lot of different areas of Revit that are actually using parallel processing.
What about the rest of Revit? Why aren't there more areas that are parallelized?
It's a fantastic question. The reason that a lot of other areas in Revit are parallelized, there's quite a few reasons. The first one is that it can be. We've done a number of experiments in terms of how things are implemented. So parallel processing implies that you're trying to do the same amount of processing in parallel, right? The thing is, if those threads or those processes have to wait for each other, that process of copying data between the two and making the data available between the two may actually make the process slower. So from our experience, some areas of Revit that we've looked at doing parallel processing in actually become either don't get any faster or are about the same speed. So I think that's really the big takeaway from here is that parallel processing is not necessarily always faster. That's not to say that we can't, improve areas and do better and look for more opportunities parallelized, because some things absolutely are highly parallelizable. But some of the core experiences that we found with customers, those things we've actually found are not faster if you parallelize them. The other thing is I do really want to point out that parallel processing is a specific solution to potentially a performance problem. And it's the reason that I say it's a solution, because a lot of the time we have to think about what is the thing that you actually want us to solve by using parallel processing. And the thing you want us to solve is you want Revit to go faster, right? And get your work done faster. And a lot of the time, if we think about it from the perspective of, oh, we're just going to do the same amount of work and we're doing it all in parallel, we're not thinking about the right problem, because sometimes the answer is don't do the work in the first place, right? So if we actually reduce the amount of work, that's when we get to more scalable solutions. So as we think about how to make Revit performance faster, we are actually thinking about processing less data as well as processing data faster.
I'm curious, is it slower in some cases to parallelize because the code simply limits it, or is it simply a function of the sequence of operations, like to get from here to there, we can't simply paralyze that process?
The way that Revit thinks, right, is there are a lot of relationships between objects. So you can't kind of update one object completely in parallel. So you can't process a window separately from a wall because the two objects actually affect each other, right? There's an opening, those things. So those operations have to be done in sequence. That's a lot of why when you are updating a model, we can't just make everything in parallel because those operations do have to happen in a certain order. So yeah, absolutely. It's not just a technical code thing. It's actually the logic of the system, which there's a lot of relationships between objects and buildings, and we have to respect those as we're updating them to make sure that we deliver the value that Revit has always promised, which is that all of your models are always up to date.
Okay, then a follow-up question would be, are you saying that there's nothing more we can do, or can we do more?
I would say we absolutely can do more. Yes, there's no doubt in my mind that we can do more, and that's something that we've been looking at. Our customers, are pushing us to do more, and we 100% agree with you. We've had a number of conversations in the near past, in the long-term past. We're always looking for opportunities to do that better. But I think that you are making a really valid point right now that we need to invest even more in it so that we see greater and greater gains, because I know that we've spent quite a bit of time improving things. We can spend more time and get things to be even faster because you are creating bigger and bigger, more detailed models.
Thanks, Sasha. Harlan, this is a familiar topic to some of us Revit dinosaurs, but what are important factors to consider for optimal Revit performance?
A lot of what it comes down to is the hardware that you have on your machine and what's available to you, starting off with the CPU. As Sasha kind of mentioned, we do take advantage of multiple cores on the CPU, but ultimately also single core performance matters. But it's not just about how fast the CPU is. It's about, kind of how fast overall it is in concert with things like its cache size, how big it can, how much data it can transfer, how quickly it can do that, not just how fast it computes things. So you have to kind of look at the overall package as well. And multiple cores definitely matters. But as long as you're kind of taking advantage of a modern CPU, in most cases, you're going to be fine running Revit in that situation. Another big thing that obviously comes up is memory. And in particular for Revit, we have kind of this, what we call the 20x model rule, 20x the size of memory that you need in order to open that model. And that's really because Revit, in order to operate and actually work on that project, opens the model in memory, not just running it off of your disk. So in order to actually not be paging and be working in that model, you need to actually have the amount of memory required to be able to manipulate that. And also you have to think about other applications that you might be running at the same time behind the scenes. Like if you're running a bunch of other apps or Chrome open and lots of things and you're multitasking, the amount of memory really can make a difference because as you consume more, it becomes slower. And also memory speed can have a big impact as well. Speed in general, the more is better, as a lot of folks like to say. And memory speed is one of those kind of things that's a little bit more tricky to get a handle on, because often, like if you just buy the fastest memory and stick it into your machine, you might actually be missing out on performance because you can actually have to adjust the memory speed, because by default, a lot of systems will just assume it's a certain speed and won't actually take advantage of what's available to you. So you have to be careful about actually making sure that you're getting what you're paid for in a lot of cases. And speaking of speed, the other big thing is SSDs and storage. Now, again, we open most of the models in memory, but to actually load those models in SSD can make a big difference. And the other thing that actually has an impact when it comes to SSDs is point clouds, because point clouds can be very large. Loading them off of an SSD makes a big difference when you're manipulating and working with a point cloud. The last thing really is about the GPU that we'll talk about. Now, Revit's not really a GPU-bound application at its core. It's very much more CPU-focused. But recently, we've made some enhancements that do depend more heavily on the GPU. And so, the biggest trade-off you're going to look at when it comes to GPUs are whether or not you're going to go with a gaming GPU or like a professional grade card. Now, there's obviously can be a huge price difference there. But basically what you're trading off is stability and performance, stability and support for that card, not performance necessarily, versus a gaming card or a pro card. And the big difference is in drivers. So typically like a professional card has much more stable drivers that are updated a lot slower, or gaming cards update their drivers just by default a lot faster in order to address new games coming out and new driver updates. But you can work around that by simply updating, sticking with a stable driver, or in a lot of cases now, hardware vendors are providing like studio or professional grade drivers for their gaming GPUs, which also can lead to, kind of just better stability overall. So that's probably the biggest thing. The thing about, professional cards that doesn't really matter that much for Revit is the amount of RAM that's included. We do need today, if you're using Revit 2021, about 4 gigs of RAM in order to take full advantage. But beyond that, it's not going to have as big an impact. So you don't need, 24 gigs of RAM just for Revit, but you might want to consider that for other applications. There's obviously lots of use cases for that as well. So you have to kind of balance out also your hardware requirements with not just Revit, but what other things are you running? And, how does that make sense? Because lots of applications have different things. The last point I want to make, though, that I think is really critical, and it's a story that goes back to my support days, actually, is about thermals. And you may be like, what are you talking about? But heat is actually a critical component of any system, whether that be a laptop or a desktop, and how the system manages heat. Because any CPU, GPU, or memory is impacted and can throttle based on the amount of heat that it's giving off. And it can cause other problems like stability, like you can literally crash your machine if it's running too hot. The story that I have from support is we had a customer contact us and say, my machine is crashing all the time. I don't understand why this machine, I just bought it. It's crashing every time I run this application. I don't get it. What's going on? And we troubleshot and tried to figure out, what is going on in the software to cause this? And we couldn't find anything. And finally, about a week later, the customer contacted us and said, oh my God, I found out what it was. I propped the machine up on a 2x4 and it stopped crashing because they had accurate air, good airflow to the system, and all of a sudden the components were working. So being able to actually have a high performance system is not just about, the actual components and how fast they are, but the holistic view of the system as well. And that makes a huge impact overall.
Yeah, it's the weakest link.
Often it's the thing that gets missed, and that's one of the things, laptops in particular, modern laptops that are really thin and light, you have to kind of be careful about that aspect of working on those machines, because if it gets hot in your hands, chances are it's thermal throttling at some point and you're going to lose performance.
Yeah, well, I was thinking as you were talking about how big a deal the 3 gig switch was when we had 32-bit operating systems years ago, and how far we've progressed to where, I'm sitting here with a gaming laptop on a stand with liquid cooling and 64 gigs of RAM and a 16, gigabyte video card and a blazing fast processor. And, Revit's, I can run 10 Revit sessions simultaneously.
I would just say, thank God we don't have to worry about that 3 gig switch anymore. And 64-bit. Wow. That really had foundationally changed fundamentally the amount of, the size of models you could work on, because we were loaded, we still load them into memory today. And that is, a huge part of it.
But that part of the, your advice is still true, right? I probably, above all else, RAM wins. Like, you need to have an appropriate amount of memory before anything else. I mean, SSDs are almost taken for granted on a new computer purchase, but you'll notice immediately if you don't have enough RAM for the application. Virtual right. Or swap files,
for how big of a model you're working on, absolutely. And as long as you're, like I said, using a modern CPU and a pretty modern GPU, you're in good shape. Like, you're not gonna run into a huge amount of bottlenecks with either of those. But in both cases, higher clock speed for the CPU makes a difference when you can think about either single core, but also multi-core. Multi-core clock speed will matter on these things. If your CPU isn't taking advantage, it like throttles down when you're accessing more cores, that's not going to help.
So as a follow-on to that, then, is there anything you've done to significantly improve performance recently, last couple of releases?
Yes, absolutely. We've done a lot over the last couple of years in particular to improve performance. One of the biggest things that we've done actually is with realistic views. And this goes to my GPU comment before. This is one of the things we did in Revit 2021 that just released, is enabled what we call global illumination inside of Revit's realistic views. So we replaced the old realistic views with a new engine. And this new engine is basically 10 times faster and can handle hundreds of lights at the same time. So artificial and the sun all displaying at the same time in the view and allowing you to have real-time navigation and orbiting and with walk mode flying through the model at the same time. And that's actually leveraging the GPU in particular and your GPU memory to actually power that experience.
Yeah, I was going to say, this is where GPU comes into play, right? Up to at least a certain point.
This is actually what comes into play for sure. We've done other things over the years as well, like occlusion culling, allow navigation with redraw, which is a feature that allows you to very easily, when with a big model open, kind of like Navisworks, where you'd orbit and things would drop out of the view, taking advantage again of that technology as well to speed things up graphically, like Sasha had mentioned earlier. Another recent addition is with RCW, or Revit Cloud Models. That's what we call it. In Revit 2021.1, we now enabled faster loading of those models. And the reason we do this is now we can actually batch loading your models based on your network speed, which is a huge enhancement. I think it was up to 30%, Sasha, I want to say, or something like, I don't remember the number.
Yeah, I think it's about right. It really depends on the model, your network speed and things like that. But in some cases, yeah, you're going to get significant boost in performance.
Another big thing, though, that we added, I think back in 2019, was what we call Noble, which is basically background computing happening on the machine. And this is in particular for things like structural steel connections, which allow you to actually process those connections on a worker. You may see this if you spin up and launch Revit and start manipulating. You see this thing in the task manager called the Revit worker, which is literally another process of Revit spun up in the background in order to process geometry. And not just geometry, but other things as well. I think MEP, like color fills, was probably one of the first uses of this framework, but we're continuing to add to that and adding additional functionality that takes advantage when it makes sense to actually process it in the background so that you're not blocked while working. The other thing I just want to mention, I mean, we've made over the years like hundreds and hundreds of smaller performance enhancements that we call out in our release notes. I'm not going to go through them all now. There's simply kind of too many, but things come to mind about how walls and like pipes and ducts display at small when you're zoomed really far out, and how they actually represent their geometry, for example. Those are, I mean, there's so many of them, and we're making changes every single year.
Yeah, I mean, I can vouch for that, saying I think we covered 50 new features at the product launch of Revit 2021. And those were just the features that made sense to talk about, as opposed to everything that was in the release notes. But
yeah, the release notes really have some gems in them. So it's actually, we have people who write us kind of emails and say, "Oh my gosh, I can't believe you guys actually did this. This is the greatest thing ever." And it's, one sentence release note. So
yeah, maybe in response to that same company's support tickets or something in some cases. So Sasha, a lot of people see that we're investing across multiple industries, multiple products and services here at Autodesk. Is that taking away from Revit development?
That it's a very interesting question. So I would say, from my perspective, no, at the end of the day, because what happens as we, as the Revit team, benefit from the technologies that are being developed at by other teams. In particular, a lot of the time we actually work with cross-company teams where we get the brightest minds who really are interested in something together, and they develop technologies or components that we can integrate. So even if they're not, part of the Revit team, we actually, as the developers of Revit and you as customers, benefit from that. One of those examples is what we call our One Graphics System, or OGS. This is the tool behind what you see with realistic views. So that was a joint effort between the Revit team and the OGS team, who worked together and developed this thing. But essentially we were boosted. But now other products at Autodesk can also benefit from that, not just Revit. And those kind of things go in, in different directions. A lot of the time, features and functionalities that we get in Revit in terms of how things are drawn actually come because they're developed for another tool of Autodesk at Autodesk that's using the same graphic system. So a lot of it is we are really benefiting from that ecosystem, and I think we are actually in a way stronger as Autodesk because we can do those things together. Another great example that's happening right now is we have an extended reality core team. This team covers augmented reality, virtual reality, and thinking about it. But again, hopefully the outcome of this effort will be something that where every single product at Autodesk benefits and has a consistent experience. And so we don't have to do something in Revit and you have to learn something else if you're using 3ds Max. You can basically use those processes together and we can really benefit. And I think that is the big thing about having a large company with a lot of products, because we benefit in many different ways that we never would have been able to if we're just one product and focused only on Revit.
Yeah, what I'm kind of hearing is that while no team has infinite resources, there are many opportunities for synergies and or interoperability here, just simply due to the breadth of the portfolio.
Yeah, absolutely. And I think another one, most of our customers heard about is this idea of Forge and the fact that we are building out a platform. A lot of the time it comes out as a platform that we're offering to third-party developers, but what's happening is we are actually building on it ourselves, right? So we are building the tools on which we will build future products or even enhance existing products. And I think having that platform approach is the thing that makes Revit so powerful and so capable of supporting so many different workflows. And I love the fact that we are actually starting to think about that at a company-wide level. So like the benefits that you get from Revit being available for MEP and architecture and structure, now you can start to get those same kind of benefits between even different industries.
Yeah, I've been impressed with the size of that team. It's actually a really significant development effort for Autodesk, but B, in conversations with Autodesk users, it's a new conversation we can have. They could actually very easily become Forge developers, and things that would have been hard to achieve in terms of customization or configuration are becoming easier.
I think our goals at the end of the day are to provide a platform that's open enough for for our customers to customize, for third parties to customize, and for us to build on, because we actually believe that ecosystem is the thing that really makes our tools powerful. So we can't build everything. We, just like everybody else, we are resource constrained, but if we can make that open and accessible, then the workflows that we can't get to, somebody else can augment.
All right, thanks, Sasha. Speaking of partners, Harlan, do you collaborate with hardware vendors to optimize performance?
Yeah, absolutely. We collaborate with vendors across, a wide range of different things, from, CPUs to GPUs, and collaborate with them on, assessing performance of our tools, and working with them to actually understand if there's optimizations that we can do or not do, but also on individual projects. So we work with them to, facilitate a new technology or a new point of view that we can leverage within our tools. The example I mentioned earlier, like occlusion culling, was one of those examples where we worked with the hardware vendors to be able to make that happen. One of the things that's most important for us when we work with these vendors is making sure that what solutions we're providing are also generically applicable, meaning they're not hardware specific for any one thing, and that we can actually leverage them for any Revit customer, for anyone using our tools, whether that be GPU, and looking at how do we handle that for integrated graphics, for example, and making sure that the product also gets that benefit, which is a huge part of it as well.
And I think the other thing to add on here is that we also do collaborate with software vendors as well. So, recently we collaborated really extensively with AWS and with Amazon, basically trying to build out a more scalable infrastructure that will be more stable for Revit Cloud work sharing in the future. And so there's a lot of those collaborations that are going on. And this is kind of a teaser, because I'm hoping that one of these sessions coming up we'll actually talk about cloud services and resiliency and what we're doing there. So kind of if that is of interest to you, keep your eyes out because we'll be doing more of these, and I'm hoping that that ends up being a topic in one of the future sessions.
Cool. Nice teaser there, Sasha. So back to Harlan. So how does the Revit team test, validate this performance?
We test and validate Revit again in performance in a number of different ways. We don't really do much like actual benchmarking, especially with comparing different hardware vendors. But what we do is actually do performance testing and what we call regression testing. And this actually happens every single day with every single code commit, every single time we make a change. We're actually running thousands of tests to validate how we're doing performance-wise against all their prior releases, so that we can understand, hey, are we making things better or are things getting worse? And anytime we're seeing problems, we jump on those and address them right away to make sure that we're not introducing any performance problems, but also on projects that are specifically to improve, making sure we're actually getting the benefits we're talking. And those tests, basically time tons of different actions. And in the course of that, actually, we leverage the community, kind of funnily enough. We use like RFO Benchmark, which is the Revit Forum benchmark that's available for anyone to run on their system. We run that ourselves against the new versions and the versions that were previously worked on for Revit and compare like how are we doing in comparison to what a customer would see as well. And that's a huge part of just daily operations actually for us.
I kind of remember back in the old Waltham office days when there was one server in a corner and then it became like 92 servers at some point that were running regression tests.
Yeah, we run, it's got to be thousands and thousands of tests. And that, as teams work on things that change behavior, you can imagine they have to update. We're updating and changing all of our testing all the time, to obviously track and make sure that we're testing what's actually available in the product. And it's a huge part of our development culture, actually, to make sure that those tests are running and that we're not introducing any problems.
Yeah, absolutely. I can tell you as having been a developer, those things were really important for us to fix and fix quickly. A lot of the amazing thing is, we'll have 10,000 tests. I think we're much higher than that at this point overall, beyond performance, but one test will catch one issue and you're thinking, oh, I can't believe I actually broke that. But fortunately, we have those tests because that would be impossible for somebody to test manually.
I think it'd be fair to say that one of the strengths of Revit, one of the reasons it's so well trusted is due to its stability. So it seems like you all are doing a good job there. Sasha, I'll go to you next. What's on your roadmap for performance and scalability?
Yeah, so the roadmap, this is kind of a big deal because we have been talking over the last, Harlan can will probably nod to this. We've been talking over the last few years about the fact that we keep hearing that, kept hearing that our customers are starting to push up against limits of the software again. Because back in the 2014 to 2016 release, we spent a lot of time figuring out how to make Revit faster. And everybody was very excited because all of a sudden models were, super fast. Everybody was saying, okay, I can do this. And what's happened since that time is that people are starting to put more and more detail in their models and bigger models and become more confident. And now we've started to push up against those, newly discovered limits of where the software is. So we've been talking over the course, of the last few years, saying, okay, we need to start, have a specific period of time where we focus on that large model performance problems. This has been on our, 3-year roadmap for a while. Now, it takes a while for projects to get, into flight, but this was absolutely something we wanted to talk about. So we kind of love the reinforcement we've gotten from our customers and kind of the very clear message saying, no, you really, really need to do this right now because that makes it much easier to move to the forefront and say, okay, now we are going to do it. So yeah, it's absolutely on our roadmap to address. I'm not going to tell you what the specific projects are because of what a lot of the time what we do is we basically take models, we experiment with them, and we say, okay, what are the actual, problems that our customers are experiencing and how do we solve them best. So we have a number of ideas about projects that we can do, but at the same time, we also base it on experiments and conversations with customers and actually working with real life models to identify what we can improve.
It's an interesting dilemma because it's always this race between whether it's hardware, the software, or the work we're doing that's pushing the hardest, right? And I mean, this used to be, I think, more visible. Now, hardware has just made leaps and bounds in its capabilities for what you spend. You know, the cost of access to high end hardware has really dropped over the years. The software has become much more capable, but humans always find a way to fill whatever space is given. So, you know, we can't stop, right?
Absolutely. I think we had Carl and I had an ex-boss whose analogy was it's like a highway, right? You can build your highway, but sooner or later there's traffic, a jam, and you have to expand the highway, but that only gets you so far, right? You actually have to try to figure out, maybe can you introduce, buses or trains so that, there's actually fewer people on the highway. And those are the ways we actually have to think about performance.
So, what can customers do about models that aren't performing for them right now?
Yeah, and I realize that's one of the biggest pain points because we'll talk to customers, say, Revit's slow, and the first question I have for our customer is, well, which part of Revit? What is it that you're actually doing that is slow? Because that can be such a significant impact on what we can do about it. And I think the key thing here is not all models are created equal. The super strength of Revit is that you can do whatever you want in Revit. The challenge of Revit is you can do whatever you want in Revit, and sometimes some decisions that you make may result in suboptimal performance. Now, the reason that those things result in suboptimal performance, and I quote one of our software architects, is due to stupid coding mistakes a lot of the time. And those are things that are actually very specific to those models. It's a very small subset of models. They are kind of extreme conditions under which Revit has not been tested, and they were coded in a way that just does not support that. And a lot of the time, we can't find those things, again, because they don't lend themselves very well to testing until we actually get your model. We need your model to say, oh, well, that was, we really need to fix that. We can actually do something about it. So I think this is the part where I'm going to say, we actually want to get your models because we want to see what you're experiencing. So we are asking you, I'm putting out a call here. Hopefully all of you watching are going to do this. We want to get your models. So that, especially ones that have, like, if you're removing a wall and it's really slow, okay, that's great. We need that description of, like, when I move this wall, it, takes 5 seconds to move, and that's, unacceptable. Please investigate it. And what we'll do is we will actually look at your models and see if there are opportunities for us to improve. So in terms of the call to action for all of you guys, if you can please go ahead. If you have a problem log like that, and you're like, is there something we can do about it? Please file a case with Autodesk support. And then once you have a case number that you have filed there, and this is the best way for us to get your model so that we're all covered. And then, obviously we are not going to do anything with your model, by the way, purely just for testing purposes. And once you have that, please go ahead and send your case number to us. This is going to go to the Revit product management team at revitperformance@autodesk.com. And what we'll do is we're going to start gathering kind of this series of models. And I talked about, we need to look at models and figure out what we can improve. So as we kick off our efforts around large model performance, we will have that repository. And then maybe in the process, we'll actually provide you some feedback saying, hey, if you fix this thing in your model, or change this thing in your model, it'll actually perform way better. So please do send us your models. We'd love to see them, because hopefully we can make a difference for you in the short term, as well as thinking about model performance in the long term.
Thanks, Sasha. Any final thoughts from either Harlan or Sasha on performance?
One thing I just want to say is, from our perspective, this is something that, gets repeated, I think, ad nauseum, but it's really true for us. And it goes to why, we have this call to action for you to provide models. For us, feedback is a gift, like the ability to hear what you're saying, to listen to you, to see all the comments and commentary. We don't view this as a negative. We view this as a huge gift and a positive thing, so that we can get better and we can improve. And you providing us, your experiences as customers and, working in Revit, working on models is nothing but helpful. So just want to say, keep it up. And we love getting that feedback.
I completely agree. We are always open to having a conversation. Please reach out to us. You can find us on LinkedIn. You can find us on Twitter. lots of ways to get in touch with us. We're happy to learn from your experience. And if there's something that you're like, I really, really need to tell the Revit team this, just reach out. We'd love to hear from you.
All right. Well, with that, thanks to my guests today, and thank you for those who stuck around and listened to us. Please respond. Please send your models to Sasha and Harlan. Please give us your feedback on the session, and we'll look forward to seeing you again soon.